Welcome back, guys. We will continue on our discussion on the ellipse. This time, we'll answer problems regarding ellipse. So let's start with the first problem. Give the coordinates of the center, foci, vertices, and co-vertices of the ellipse with the given equation. We shall sketch as well the graph and include all these points. So this type of problems, we need to be assured that the equation that we have is in its standard form. Is it in its standard form? Almost, since the denominators are not expressed in their power forms, so it's almost on standard form. However, we can already extract some information from them, including the center. So the location of the center is found at -3, +5, and the denominator of the y variable is greater than the denominator of the x variable. So we know that this is a vertical ellipse, which means that a squared is equal to 49, a is 7, b squared is equal to 24. So b will be square root of 24, which is approximately equal to 4.9. Now what will be c? We need to find c. So a squared is equal to b squared plus c squared. We need to remember that always. This equation is very important in the ellipse. Now c squared will now be the difference of a squared and b squared. So c squared will be 49 minus 24. So 49 and 24 over there. So which means that c squared is equal to 25, or c is just 5. So after extracting all of this information, we already know the value of a, b, and c. Okay, there is a, there is b, and there is c, as well as our center. We can now proceed in graphing our ellipse. So it's graph on the next slide. Let's just verify it. So again, in this case, c is 5, a was 7, and b is 4.9 with the center. So our center is at -3, 5. Now let's verify. So our center is at -3, 5, and from the center towards one of the foci, that is c, you see that is 5, and from c to our vertex is 7. Okay, that is 7, and from our center towards one of our co-vertex, that's 4.9. So you are able to graph the ellipse. So for us to graph the ellipse, the thing that we need to get first is its standard form. And after getting the standard form, you shall get the center and all these values A, B, and C. So we move on to the next problem. Give the coordinates of the center, foci, vertices, and co-vertices of the ellipse with the given equation. Sketch a graph and include these points. However, in our problem here, our equation is not on its standard form. We have to transform it first. So you're gonna transform that, and remembering that if we are transforming an equation from general to its standard form, we need to group the terms first. So we start by grouping the terms. So 9 x squared shall be grouped with 126 x, since both of them are x terms, plus 16 y squared plus 64, since both of them are also y terms, is equal to 71. Our constant will be isolated on the right hand side of our equation. Next will be to extract. So we're gonna extract 9 and 16. Okay, so we're gonna extract them. Extract the coefficients of our second degree variables. So what will happen next? So we have 9 open parentheses x squared, 9x squared divided by 9, that's just x squared, and negative 126x divided by 9, that's negative 14x. Then we are gonna put a space here, since we are trying to achieve a perfect square trinomial. Same will be said here. So extracting 16 again. Now 16y squared divided by 16, that's just y squared. Then 64 divided by 16, that will be equal to 4y, plus trying to achieve a perfect square trinomial again, now equal to 71. Then we are gonna add what will be derived from it later on. So what shall we add here inside our parentheses? So remembering that we have to get the half of this and square that, so negative 14 divided by 2, that's negative 7, squaring that, that's 49. So that thing 49 times 9 shall be added here, so 49 times 9, so we just write 49 times 9. We don't have a lot of space, so I'm writing it that way. I hope you understand. So again, take the half of this 4 and square that. 4 divided by 2 is square, so that's just 4. Now we have 4 times 16. Now 4 times 16, that's easily answered, that's equal to 64. So 71 plus 49 times 9 times 16 times 4, or 64. Next, we're gonna change this as the square of a binomial, this one. Again, x minus 7 squared. Negative 7 is from the half of our middle term, plus 16 times y plus 2 squared. Now 2 is the half of our middle term. Okay, so 2 is the half of our middle term. Then we are going to add this 71 plus 49 times 9 plus 64. Fortunately, I know the answer to that. That's 576. We're almost done. We can actually get the center here. The center is 7, negative 2. Now, if you wanna try to transform it in standard form, remember to turn the constant on the right hand side of the equation to 1. So we divide it by itself. Divide by 576. So dividing by 576. So we don't have much space here. So I'm gonna erase this all. Rewrite it. Rewrite just the last part. Okay. So we're gonna rewrite that last part. So 9 open parenthesis x minus 7 squared plus 16 times y plus 2 squared is equal to 576. So we're dividing by 576 both sides of the equation. Now we're almost done. 576 divided by 9, that will be x, gonna conserve some space, x minus 7 squared. So 576 divided by 9, that is 64. Okay, 64 is 8 squared. So instead of 64, we write 8 squared. Plus 576 divided by 16. So we have y plus 2 squared. 576 divided by 16 is 36. But since that is 36, we write 6 squared instead, is equal to 1. We have now achieved our standard form. So since the greater denominator is under x, we have a horizontal ellipse with the center. Our center is at positive 7, positive 7, negative 2, with a is equal to 8, b equal to 6, and c here will be equal to 5.3. I'm not gonna show you how 5.3 has been derived, but just remember the equation a squared is equal to b squared plus c squared. After doing this, you'll get this. Okay, so c will now be equal to 5.3. So let's see its graph. It's on the next slide. So again, our center is at 7, negative 2. So it's right there. And a is equal to 8. So that is 8. Now, from 7 to 15, that's 8. And our C, that's again 5.3. So you see, that's C over here, that's 5.3. That's more than 5. So 5.3. And B, is 6. So that is 6. Okay, so that's it. Now there's something different. An ellipse has vertices 2 positive square root of 61 minus 5 and 2 minus square root of 61 negative 5, and its minor axis is 12 units long. Find its standard equation and its foci. What things can we get from this? First, we already know the vertices. So the vertices are right there. So these are the two vertices. So the two vertices, yeah, so those are the two vertices there. And the minor axis is 12 units long, which means that half of our minor axis is B. So since our minor axis is 12, which means that B is 6. And for us to get the center, we need to get the midpoint of these 2 points. So the midpoint formula will look like this. So midpoint formula, so we're gonna get the midpoint of that. So the midpoint will be, just add the x terms and divide by 2, and same with y terms. So 2 plus square root of 61 plus 2 minus square root of 61, we divide by 2, that is for x, and y. Now y coordinate negative 5 plus negative 5, then we divide by 2. So positive square root of 61, negative square root of 61 will cancel out. So our midpoint will be 2 plus 2, 4 divided by 2, that is 2. And negative 5 plus negative 5, negative 10 divided by 2, that's just negative 5, which means this is our center. Okay, so we can actually give some parts of our equation. So let's try. So we have x minus 2 squared plus y plus 5 squared is equal to 1. We know b. However, where shall we put b? Is it under x or is it under y? Since our ellipse has vertices on 2 plus square root of 61 minus 5 and 2 minus square root of 61 minus 5, negative 5 is their common ordinate. So which means we have a horizontal ellipse. So b shall be under y. So couldn't write it here legibly, so there should be 6 squared over here. Still we don't know what is a. However, if we know B already and the location of the center and actually the vertices, we can get A. So we need to first get A. So I'm gonna erase all of this and try to get A from the information that we have. So we're gonna get A since that's the only thing that is missing. So how do we get A? First, we need to get the distance between the center and one of the vertex. So what will be the distance? Since C will just be the distance from the center. Again, the center has already been given. It's center, have to write that again. Center, that's 2, -5, and we need one of the vertices, so we'll just get the distance from them. Since we don't need actually to use the distance formula here, since they just lie on a horizontal line. Just get the difference of these two. 2 plus square root of 61 and 2, that will be the distance. 2 plus square root of 61 minus 2, that will be enough for us to get C. So C now will be equal to square root of 61. So C squared is equal to 61. Remembering that B squared will be 6 times 6, 36. So A squared is equal to B squared plus C squared. So A squared will be 36 plus 61. So A squared will now be 97, which means we can already give the equation. That's just our goal. So our equation will now be equal to x minus 2 squared. It's there. I think I have to change the color. Okay, so x minus 2 squared over our a squared, 97, that will be enough, plus y plus 5 from this here squared over 36 is equal to 1. So that's the standard equation, and we have already found the foci. So foci will just be just get the distance. You can do that. Okay, we move on to the last example. So give the equation of the ellipse below whose foci lay on -2110. So the foci are here. So let's say this is f1, foci 1, and this is foci 2, and -915 here is a point. It's a point. Okay, first we need to get the equation, the location of the center. The location of the center will be the midpoint of these 2 points, -2110 and +310. So the midpoint of those 2 points will be, since they lay horizontally alike, we know that their ordinate will just be the same. So what's the midpoint of -21 and 3? the midpoint will be negative 21 plus 3, negative 18 divided by 2. That will be negative 9. So our midpoint is now our center. So this is also our center. Okay, so center. We need to get some points here. Now C, you can get C here. C will just be the distance between this. Now C, what's the distance between from negative 21 to negative 21 10 to negative 9 10? That is 12, right? So negative 21 minus negative 9, that's negative 12, but we need a positive 1, so that should be 12, which means that C squared is equal to 144. Okay, so we already know C, however we don't know A and B. So to get A and B, we need first to remember this one. We know that P F1 plus P F2 is equal to 2A. This is the definition of our ellipse. So I need a lot more space here. So I'm gonna use the things here to get A. Okay, so just remember that C is already 12. Now P F1 plus P F2 is equal to 2A. Now what's the distance between P F1? So point F1 to point F2, we're gonna get the distance between them. That will be the square root of, let this be our point 1, negative 9 15. So negative 9 minus, okay, negative 21 squared. What we're doing is the distance formula, and we have 15 minus 10, so 15 minus 10 squared. That's just PF1 plus square root of PF2. So negative 9 is still minus 3 squared plus still 15 minus 10, so 10 squared, and this will always be equal to 2A. Okay, so this will now be equal to negative 9 minus negative 21, that's just positive 12 squared, that's 144. Then 15 minus 10, that's 5, square that's 25. Plus square root of negative 9 minus 3, that is negative 12 squared, that's again 144 plus still 25 is equal to 2A. So square root of 144 plus square root of 21 will be square root of 169. Okay, rings a bell. Square root of 169 is just 13. So instead, we write 13 here. 13 plus 13 is equal to 2a. So 2a now will be 26. So we divide both sides by 2. A now will now be equal to 13. So once we get A and we get C, we can get B. So B here will be equal to 5. Okay, so since we already know A, B, and C as well as the center, so our center again is at negative 9, 10. We can now give the equation. Okay, so what will be our equation here? This is a horizontal ellipse, so our equation will look like this. Again, center is at negative 9, 10. Okay, so we have x plus 9 squared over our a is 13 squared plus y minus 10 squared over our b is 5, so 5 squared now equal to 1. This is now our equation. So that's it. Our next video will now be on the hyperbola. See you guys.